we have a newly acquired piece of test equipment. It's a power supply, a high voltage power supply, Heathkit PS-4, model PS-4. It's obviously missing the covers to the binding posts, or whatever you want to call these. I knew that that was a problem, so I ordered some replacements. I'm sure there's other problems with it, but I ordered some replacements. I don't have a tool to tighten them, but I'll figure it out. They're not too expensive. They are rated for 1,000 volts DC, so they're good to go for this. This can make up to 400, I believe, yeah, 400 volts at 100 milliamps, so what, 1 amp, 100 milliamp. It has your heater voltage for your tube, 6.3 AC, and negative C in your B+. So you could, if you're having problems with your power supply in your radio, I suppose, you could use this to supply voltage to it. And you switch back and forth between them here and here. Off, standby, and on. So standby, I believe it's basically just running the tube elements. So it keeps the tubes warm. So when you flip it to on, it's ready to go. When you're not using it, you can turn it back to standby. Binding post should be dead. But when you're ready to roll again, you just flip it and she's good to go. So this could help us in troubleshooting too, if there's a problem down the road, possibly, right? So the condition of it is fair. I mean, it needs to be cleaned. It looks like there's a small dent here on the top, right here in the cover. That's okay. I'm all right with that. The case itself looks to be, you know, is old. I don't know how old this is, but there's some chipping on the paint. You know, it's probably to be expected. Let's look at the other side here. Yeah, there's a dent right here. There's a dent in the side of this. I don't know if I'll fix that or not. If it prevents it from going in someplace tight, I will have to beat it out. I don't think it'd be that big a deal to get that out of there. But you can see the paint's missing too. And this textured paint, I'm not sure if you can use like there's a dent here in the top too, I just noticed. If you can use that crinkle paint that they do valve covers. I know Hondas are famous. Honda guys like to do that, the crinkle paint on the valve cover. And in the back, I imagine this is the original power cord because it is kind of stiff in it. I seen it was corroded, so I cleaned it up a bit. There was some corrosion on it, and I knew we were going to be plugging it in. There is a fuse, and I believe it's a 1.5 amp fuse. I'll have to look again. And it looks like the typical Heathkit setup, the 2 screws in the back, and then this slides off. There should be a chassis in here, I believe, and then the front cover will stay with everything in this box, this different colored box. This lunch box will come off. It can be a little tricky to get these things in and out sometimes. I messed with a couple of Heathkit pieces of equipment in the past that I've... So, we'll get into this now. I don't think there's much more to see. We'll look at the bottom here. Yeah, it's got the push-in feet. It's got push-in feet, but 2 of them are missing down on the bottom, so I'm going to have to come up with some feet for this. And these probably need to be replaced anyway. They're hard as rocks. They should have some grip so it doesn't slide around on your bench. Okay, so I think I don't like laying them on the front here. There is a little bit something going on with that meter. Looked like maybe some chemical got spilled on it. I'm hoping that's not inside of it. If I have to, I'll remove it, but see, it's kind of unclear right here. Oh, you can't see that. Yeah, right here, there's something going on here, and I don't really feel anything. Maybe something got spilled on. I might be able to clean the outside of it, but it don't look like it's coming off. Hope it's not on the inside of this, because I don't know if these covers come off of these meters. I don't know if I want to mess with that as well. Okay, well, I'll do what I can with it. So I think first thing to do is to take the back off of it. When I get it off and out of the way, we'll come back and take a look. Well, we got it apart. And looks like there's a small transformer and a big transformer. Big difference. This is about 1 inch. This is about 2 inches. There's two big tubes and 4 smaller tubes. We'll get those out and look at them and test them later. There's some corrosion going on the transformer. Both transformers. Probably have to sand and paint. Not my not what I want to do, but I will. I don't want these, if these are still good, if these transformers are still good, I want to preserve them so there's no problems down the road, right? So this thing will go another 40, 50 years or whatever. The chassis is just dirty. Looks like there's 2 adjustments right here. 2 variable resistors, I'm assuming. I'm not sure, 100%. The light, the switch, I believe your voltmeter and amp meter. I have to look, but you have your meters there. It doesn't look to be in that bad a shape, but you never know until you flip it up how much somebody's hacked on it. So we'll look at the bottom here. Yep, somebody's been in here. Oh yeah. So right off the bat, I see 2 things right off the bat. 3. Notice 3 things right now. So one of them that caught my eye right away is this capacitor has been changed. This is a 47 microfarad at 450 volts. This is bypassing the fuse. So I'm assuming there is no fuse in it. Yep, no fuse. So why would they bypass the fuse? I'm betting bad capacitors. Making it draw too many amps. So when you plug something in, if this was a 1.5 amp fuse, and one of these, especially these guys, these electrolytics that are connected to ground, drawing too many amps, bleeding voltage, leaking electrically, and then you plug something in here that draws X number of amps that are within this fuse tolerance, but because your capacitor, one of your capacitors are leaking, probably blew the fuse, and their fix was to do this. So now I see this, I'm wondering about the transformers now. I don't see any melting. They didn't look like they overheated, so it's probably okay. The third thing I've seen is right here is a big blob of solder on this resistor. Did they cut that resistor and solder it back together? Let's see if we can zoom in a little bit there and see it. There's a big blob of solder right here. That caught my eye right away. This looks like this has been looks like there's been some rework in here. Not a whole lot, but these were kits, right? Heathkit. So you would buy this in a kit form, or you could buy it in a kit form and, pardon me, and assemble it and follow the instructions. I have looked online and I cannot find a manual for this. An assembly manual, you know, owner's manual. I found wiring diagrams, but that's it. No manuals. And that seems strange to me for Heathkit. Heathkit stuff is, you know, their manuals are online, most of them. Most of the Heathkit stuff that I've worked on or been around, there's manuals online for it. So, looks like somebody's written in here V1, but nothing written anywhere else. So, maybe when they were assembling it, they started marking stuff and then thought, oh, I don't need to do that. It's pretty simple. I don't know. We'll have to dig into this some, but these resistors, it's got black mark on it. Yeah, I'm wondering if somebody had troubleshot this. We'll see. We'll have to check resistors and stuff. I'll go through stuff and see what I can find here. I'm not even going to check these capacitors. I'm just going to change them here eventually. But let's... I guess we could plug it in and see if it works, what happens here, and what we have for voltages. Right. Bring it up slow on the Variac. I had that. So we'll put it to the on position. Bring a voltmeter over here. Oh yeah, wanted to tell you. Somebody's definitely been in this. This was a big clue. When I took it apart, the screw lengths weren't the same. The back cover screw lengths were a different length. So I knew right away that somebody had been in it. I mean, that blob of solder could have been there from when the guy assembled it too, if this came in a kit form. Heathkit, I'm assuming it did. So we're going to want DC voltage. Let me get this set up so you can see it. I don't know. I'll have to turn this a little bit this way. And okay, so that's a positive common. Master switch is over here. Let's turn this on. Okay, there's 80 volts, 85 volts. The light came on. It's drawing 0.22 amps. 20 watts. Yeah, I'm pretty sure there's a capacitor shorted. I don't think those heater... The only thing that really should be drawing any voltage or amperage right now are the heater elements in those tubes. My meter is not drawing amperage. 0.23. So I'm pretty sure we got a bad capacitor in there. Let's go ahead and crank her on up some more. Well, I hear the transformer humming. So 0.4. Alright, so we're on over here. Oh, see, I always do that to this meter. Forget to move it from resistance to voltage. So that's about 5 volts on the on the needle on the face of this. So let's take her up to 25 on the needle. So there's negative 24, and the needle is pointing right at 25. So there's 50, negative 49, 75. So that's not too far off. 80, well, there's 100. So that's, you know, I'm not going to complain. It could be my meter. There's 125 on the needle. Alright, it won't go past 100 and, is that 30? Yeah, 30, 40, 25, 30, yeah. So it's not reaching full 150 volts. What does it say maximum is? 100 at 1 milliamp. So it goes over the 100. So that side's working like it should. So where's the other? Okay, so we flipped the switch. And move the, let's see, common. So it's already showing 18 volts. Negative 18 volts. Should that not be positive? That's B plus. So something's wrong with the zeroing, obviously, because it's going into the positive range on the meter. Trying not to block your view. Now that's on the high voltage side, 125. 125 milliamp maximum, 400 volts at 1 milliamp, at 100 milliamps. So I've turned it approximately a quarter of the way. We should be around 100 volts. We're only at 15. So there's half. So we're not getting any higher than the other side, are we? 175. So 114. Yeah, we're not getting any higher. 170, a little higher. Alright, so if what I'm thinking is true, if we turn this to standby, the amperage on the meter right there should drop. So when we put this into standby, we should only be looking at the heater voltages in the tubes. So it should be around 15 point, yeah, so 0.18. So something's automatic. There's a bad capacitor. Something's bleeding voltage to ground. Look at that. Look at that jump. If it was a 1 amp fuse, we're almost a third of the way there without even having something on the front of it. Got to be careful. Those things are uncovered. Got to be careful when I'm working on this until I get those new binding posts in there. These will have voltage on them. And I'm wondering how long they're going to carry voltage after the machine's turned off. Nothing there. This all should be turned off. Look at that. There's still 60 volts there. And the machine's turned off. I'll just even turn this off. So there's a capacitor in there holding a charge. There's some good capacitors in there. But that's kind of dangerous. You turn it off and you think there's no voltage there. But there's voltage there. It's slowly bleeding off. Yeah, got to definitely be careful while I'm working on this. I'm going to end up getting zapped. It's only DC voltage. Yeah. 100, freaking 100, 300, 400. No, no thank you. I don't care how many amps are behind it. All right. So I'm wondering. I wonder what our next move is here. Could consult the interwebs. I'm sure somebody's worked on this. There's some old radio guys or somebody's got some information on it. But I think to start with is to change the electrolytic capacitors. These things are notorious. These yellow, I don't know. These old capacitors. Garbage can. Old paper electrolytic. Come on. So, yeah, this one says 0 volts. And that one says 400. So I'm wondering if this zeros everything and then this one sets your maximum at 400. So when it says 0, it's 0 at these binding posts. Instead of negative whatever that was there on that high voltage side of it, on the B+. Yeah, I wonder if these are... This looks like some sort of rectifier here. I bet you these are diodes. These look like selenium diodes to me. Seleniums, old seleniums. That might be a problem. Probably have to put... See how they're mounted in there. We have to put a terminal strip and some regular diodes in there. Some modern Zinnier or whatever diodes. Okay, that's a 0.047. This one's a 0.2 at 200. This one's at 400. So the capacitors I should have those. 70 microfarad at 300. 70, 20. I'll have to look in the schematic, see, because I don't think they had 47 microfarads back then in the old school days. This was probably a 40. This one is 220s at 350. I'm assuming that's 20 at 450. I'll have to look in the schematic. We'll have to check all of these resistors too. I'm not going to bore you with any of that. I'll go away, and when you guys come back, I think I might check resistors first, and I will mark them somehow. I'm seeing this one's got a black mark on it already. Do any of the other ones have a mark on them? This one's got a mark on it with a black marker. I'll go through here and check all of these. They're square Bradleys. I think these are Bradley type. I don't think they're the roundy ones. These are probably pretty good, but you never know. There's a precision one right here. That looks like another precision one here. This doesn't look right either, the way this is installed. I don't know if you can see that very well. I mean, why would you install it like that with that long lead sticking out this one side like that? It's just a freaking resistor. Should be nice and neat in there. And that would be between the positive of one of the 20s and off of the selenium. I'm wondering if this is even supposed to be here. We'll have to go through this and check everything with the schematic. I want this to be right when I'm done. So, alright, thanks for watching. We'll bring you back when there's something exciting to see. The amperage draw with nothing hooked to the binding posts is due to the resistor network right here, these 27K resistors. They just connect the negative voltage to the high voltage. It's kind of a bleed. I'm not quite understanding why it's there for 100%, but it has to have something to do with the biasing of some sort. I'm not sure, but this is why there's an amp draw when you switch it from standby to power on, and nothing's hooked, and both both controls are turned to 0. There are 27 ohm resistors. Let's see if we can zoom in here a bit on them. Yeah, so right there, there's 4 of them in series. I don't know why they didn't put just one big resistor in here. I'm not sure. But these are 2-watt resistors, or they're 1-watt, 2-watt. They're 2-watt resistors in here. So, and this is a voltage dividing network here for the high voltage control for the 6BH6. So I believe part of the problem with this power supply are the electrolytics. I believe all the electrolytics are bad, obviously, and these 2 smaller capacitors are bad as well. I'm sure some of these resistors are out of tolerance as well, so we'll get it all, the components changed that need to be changed, but I'm leaning towards this 6BH6 as being the problem why we can't crank it up. This is the regulator tube, because they're using these 6L6s as giant resistors, basically. Mr. Carlson did an IP32. He did a very good job of explaining how all this works, and I believe that this is the problem why our voltage won't reach full voltage. So thanks for watching, and leave a comment down below.